The really cool thing about the Arduino for tinkering is that it has so many options for input and output. For example, we've already shown how to use serial output to send text and numbers to the serial monitor. The Arduino also has digital, which is like on or off, digital input and output, and it has analog output, when that has a variable value. And both of those, there's inputs and outputs. So let's look at how this works on our Arduino. Okay, notice that there's two rows of pins. There's this row where they go from 0 to 13 are called the digital pins. And these can be digital input or output. Just remember that these first two, 0 and 1, are reserved for serial input, so input and output. So these two are really synonymous when we use the serial monitor, for example. So we really can't hook up like resistors and things there, or we're going to screw up our serial monitor output. And then the other thing to remember is pin number 13 up here is also tied in with the built-in LED. So we can use it, but we might avoid it because we might like to use the built-in LED. So whatever the LED does, that's going to do. Whatever that does, the LED is going to do. So those are kind of tied together. Oh, another thing to note is, notice that some of the pins have a squiggly little symbol next to them. And over here in the text it says PWM squiggly. So the squiggly means variable. So those particular pins can also be a form of analog output. So then over on this other side of the board we have a series of 6 pins that are called analog in. They go from A0 to A5. So those are strictly for analog input. So those read a variable voltage value into the Arduino. Now just a few things to talk about all pins in general. First off, the way the Arduino works, basically the maximum of anything is 5 volts. So both analog and digital pins, the maximum is going to be 5 volts. The other thing to keep in mind is when nothing is connected to a pin, or worse yet, if there's a wire connected with nothing on the other end of the wire, you're going to get a random input. Just you try to read a pin with nothing, you'd think, well, there's nothing there, so it would read a 0, but not necessarily. There could be just floating voltage, like static electricity or whatever on there, that it'll read it as some random value. Now this is going to be important when we hook up a button, for example, because the button is going to take a pin and either connect it to 5 volts or connect it to low volts, but there's a state in the middle where it's not connected to anything, or like say when the button is not pushed, the pin is not connected. So we've got to be careful when we read a pin that's not connected, and that can be a problem with a button. Well, the solution to that problem with a button is to connect the pin with like a very high resistance resistor to either ground or to the high voltage. So when we're not pushing the button, it kind of goes to that value that it's connected to through the resistor. In fact, this is so common that the Arduino has the capability internally to connect this little resistor. And we'll see that in a minute. So that's a little bit about buttons. Another thing I should mention, I've got on my board here, by the way, I've got a button, I've got an LED for output, and I've got this thing called a potentiometer. I should explain a little bit how a potentiometer works. Let me bring up here Here's a picture, kind of a schematic picture of a potentiometer. So there's 3 terminals to the potentiometer. So on terminal 1 and on terminal 3, I just connect a current that's there all the time. So for example, I might connect pin 1 to ground and pin 3 to 5 volts. So there's always going to be some current flowing through this they call it a resistive track. It's made of like carbon or something that conducts. It's basically a resistor built into a circle. And then the center terminal is connected to a wiper that can sweep in any position on this. So when we turn this wiper all the way over here to 1, well, the middle terminal then has the voltage of ground, which is 0. And if I turn the wiper all the way over here to this end, it's going to have 5 volts on it. If I put it somewhere in the middle, it's going to have a voltage somewhere in the middle. So it's a variable resistor, or they call it a potentiometer, or if you want to be cool, you just call it a pot. That's what everybody calls it. They call it that's a pot. So that's a little bit about the potentiometers that we're going to use here. All right, now let's talk about the values that the Arduino reads in. So for digital values, remember I said what it's going to interpret that internally is it's going to come up with a 0 or a 1. So when we put 5 volts on the pin, in the digital world it's going to call that a 1, or like true. And if I ground the pin or have no voltage, it's going to read as 0 or like false, or high and low, the 2 values. So digital basically reads 0 or 1. Now analog pins, those are going to read a input number that's between 0 and 1023. And you think, now where in the world did they come up with a number like that? Well, the reason is the way they read these pins, they use what's called 10 bits, where each bit is a binary 0 or a 1. So for example, in a 10-bit binary number, the first number 0 is a string of 10 zeros. 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, and then a 1 is 5 zeros and 4 zeros and a 1, 9 zeros and a 1, all the way up to a number that's 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, a string of 10 ones. And the maximum number that can contain is, let's explain, in base 10 numbers, each digit is like each placeholder. The first you got the ones, and then you got the tens, and then you got the hundreds and the thousands. Well, in binary, you've got the first one is 0 or 1. Then you have 2, 4, 8, 16, 32. So the maximum number of places, if you take 2, the first bit can be on or off, that's 2. The next one can be on or off, is another 2. So if you take 2 times 2 times 2 times 2 and do that 10 times, the maximum number is 1024. So that's the maximum number of accuracy that you can read in these analog inputs. So it's 1024 combinations, but the first one counts as 0. So the highest number you can read is 1023. Now, just another thing to point out is for analog output, I guess I mentioned this already, on the digital pins, some of them have a little squiggle. So those can either be, they can be digital input, digital output, or it can be an analog output. And the difference there is when we do an analog output, we have only 8 bits. So the maximum value we can write out is 255, or basically 256 values from 0 to 255. All right, well let's look at this sketch. I'm going to kind of in this sketch, we're not going to actually like do anything, but I'm going to just show you how do we read digital and analog and output digital and analog values. So first we're going to declare our variables. So the LED pin, I've got that on pin 9. I've got a button here that's hooked up to pin number 12, and I called this integer pot pin over here is hooked up to pin A0. Now this threw me for a while, that I say this is an integer variable named pot pin, and its value is A0. Now how does that look like an integer? Well, the Arduino kind of recognizes A0 as a special integer, and it knows that, well, what you really mean is 14. So these pins go from 0 to 13, and then pin A0 really starts over again at 14 internally. So I call it A0, it calls it 14. So it automatically handles that properly and converts it to a 14. Okay, then I'm going to define some integers from a digital input I'm going to read, an analog input I'm going to read, and an analog output that I'm going to send to the LED. So in my setup, I'm going to define, okay, I always define my serial monitor whether I think I'm going to need it or not, because I always do for debugging, so just put that in there. It doesn't hurt to put it in. And let's see, I don't really need that statement in there. Yeah, I'm going to put these down here. So inside our loop here, so here's where we read the digital value. I'm going to say digital read the button pin. And that's going to read, because I said pin mode for the button. Okay, let's go. I didn't explain the pin modes here. So the pin mode for the LED, I'm saying that's an output. The pin mode for the button pin, which is on number 12, it can be input, output, or this thing called input and pull up. Now input underscore pull up means tell the Arduino to put that little internal resistor to pull that pin up to the high value if nothing is connected to it that's really pulling it to the low value. So when I'm not pushing the button, it's going to read like it has 5 volts, or it's going to read positive plus 1. So here's how I read digital input. I'm going to store that value as digital input, and then I'm going to read the pot pin, and that's going to be a value from 0 to 1023, and I'm going to store that as analog input. And then I'm going to compute what I want for my analog output, and because this is only 8 bits as opposed to 10, I've got to divide by 4. So the maximum number here on my output can only be up to 255. So I'm going to put out on my LED an equivalent of an analog voltage that's 1/4 of the analog input that I read. So right away I'm going to do that analog write to the LED pin, that calculation for analog output. And then I'm going to put a bunch of prints just to keep track of what's going on, because nothing's going to really stop this from looping. So I'm going to on the digital input, we're going to read, it's going to be reading what the button is doing. On the analog input, it's going to be reading this potentiometer, this little thing that I turn here, that thing I showed you with the wiper, and we're going to output the analog output number. So I'm going to then print what these values are. Then I'm going to delay for half a second just to slow it down so you can see what's going on. Alright, I hope that's clear as mud. So we're kind of demonstrating all the different kinds of digital and analog input and output here. So let's check this code. So it verifies, it looks like it's doing okay. Okay, now I'll upload that and display my serial monitor here. Now this is going to keep looping, but notice first off where it says digital input that's flying by. And I push the button down, notice that goes to a 0. So the digital input goes, let it up, it's a 1, and I push it down, and it's a 0. So let's take my potentiometer, and if I turn it to one side, notice it says analog input is 0, and if I turn it all the way to the other side, it says 1023, and if I put it somewhere in the middle, it's going to read somewhere around 500. And notice my analog output can go from 0, or if I turn all the way up, it's going to be 255. Now watch what the LED is doing here. As I change this value, I'm dimming the LED. It's kind of hard to see it there because it kind of blasts out the display anyway. So if I turn it way down. So it's not really an analog voltage. It's what's called the pulse width modulated voltage. So it takes the 5 volts and it turns it on and off very fast. So if I wanted, half speed, it turns it on like half the time, 50% of the time. But that's actually a better way to control the LED than actually turning the voltage down, because the LED being kind of non-linear, at some point it'll quickly light off and then light on. This way it can give you a much better control from dark to bright. So I guess that's about it. The only thing I'm not showing you here is digital output. We've already shown that in other videos. Digital output would be just take a digital pin as a 0 or a 1 and put the LED on there, and it would give it either 5 volts or no volts. It would be on or off. This way we're controlling it to give a variable output. So is this cool or what? All these cool things you can do with the Arduino in terms of digital and analog and hooking up these little things. It's just really cool. Anyway, in the next video we'll talk about how do we use these inputs and outputs in our code, to do something with it. All right, see you in the next video.